Okay, let's talk about what solubility even means. Now, solubility is the ability of a known of a solute to dissolve. I'm really struggling. Okay. In this video, we are going to talk about solubility. Now, solubility is how well a solute can dissolve in a solvent. And when this happens, it will form a homogeneous mixture. And as we've already seen, that homogeneous mixture is known as a solution. Generally, it is expressed in terms of the amount of solvent or the amount of solute that can dissolve in a given amount of solvent. In this table, we can look at the solubility of cyanide containing compounds in grams of solute per 100 milliliters of solvent. So potassium cyanide is relatively soluble, and we can dissolve 50 grams of potassium cyanide in 100 milliliters of water. Well, go down to cadmium cyanide. We can only dissolve 1.7 grams of cadmium cyanide in the same amount of water. Copper 2 cyanide, we can't dissolve any. When we're talking about the solubility rules and solubility, it's generally in water. So we can use that to talk about the hydration. So hydration is just like solubility, but it is the process of water molecules completely surrounding the solute. So hydration is solubility. However, the solvent is only water. So hydration is only for water, and it's how those water molecules surround a solute. If your solute is an ionic compound, then the water molecules are going to line up in a very specific way to surround the different parts of that ionic compound. So in my water compound, my hydrogens are positive and my oxygen is partially negative. We'll zoom in a little bit to see what that looks like. So that means if I have my negative anion, this water molecule is going to align so that the hydrogen is closest to the anion. With my cation, the water molecule is going to flip and the negative oxygen is going to be closest to the cation until it completely surrounds the different components, the different ions in that substance. And this process of breaking it apart and surrounding it is hydration. And that is when something is going to be soluble in water. You are going to have the water molecules completely surround the solute. So here are the solubility rules, and these are used to determine if an ionic compound is soluble in water. So the solubility rules are used to determine if an ionic compound is soluble in water. I want to be very clear about this. This is not a complete set of solubility rules, but this works perfect for our class. You will always be given the solubility rules. You do not need to memorize them. With that being said, it's very important that you know how to use them. On this side, we're talking about how you can determine whether a compound is soluble. So all compounds containing alkali metals, so these are going to be cations in group one, ammonium, acetate, and nitrate. They are always soluble. There are no exceptions to this rule. If you have a halide, that is group seven. Remember, group seven is the halogens. If you have a halide, that means that you no longer have fluorine, you now have fluoride. So if you have a halide, they are going to be soluble, except if they're bonded with either silver, mercury 2, or lead 2. If the cation in that compound is one of these three, then it's going to be insoluble. Sulfates are very similar. They are all going to be soluble with the exception of these four cations right here. If the sulfate is bonded with any of these cations, then it is going to be insoluble. If something is soluble, that means the water molecules have completely surrounded the ionic compound and it becomes an aqueous solution. So if something is soluble, the state becomes aqueous. Now let's go to the other side of the table. Here we have the insoluble compounds. So if your compound contains carbonate, phosphate, or chromate, then it's most likely going to be insoluble. Now, remember, group one, ammonium, acetate, and nitrate are always soluble, so you're going to see those exceptions here. Now, you might be thinking to yourself, why isn't acetate and nitrate listed on the exceptions? If you notice, carbonate, phosphate, and chromium are all anions. So they can only bond with cations. They're not going to bond with, whoops, I got too ambitious with my Xing out. They're not going to bond with other anions like acetate or nitrate. So that's why they're not part of the exceptions. Hydroxide is also an insoluble compound unless we have our always soluble calcium, strontium, and barium. The same is true with sulfides, and here are the exceptions for sulfides. So it's very important that you get practice with using these rules. You don't want to try to figure out how to use them during a quiz. Let's look at some practice problems. I have something that I use that I call the N rule. I named it the N rule because my name's Natalia and I just happen to love N's. And all of the substances in the N rule start with N. So we have sodium, Na, ammonium ion, NH4 plus, and nitrate, NO3 minus. So these all start with N. Well, these are always soluble. There are no exceptions for this class of when you will find a compound that has either one of these three and it will be insoluble. They're always going to be soluble. And you'll notice that a very high percentage of the compounds will contain one of these three ions. So let's look at the first column. If I go through and just mark where sodium, ammonium, or nitrate show up, that is literally 4 out of the 7 examples. We can take this one step further. If you recall, elements within the same group are going to have similar chemical properties. So sodium ion is in group 1. So by remembering sodium, I'm remembering all of group 1. So I can take this further, and here's another group 1 cation. The other thing I do is by remembering nitrate, it is the anion that is always soluble. There is one more, acetate. So I kind of clump them together in my brain that anytime I see either of those, my compound is always going to be soluble. So once I'm done using the N rule, I see that there's really only two that I don't know the answer to. Sodium phosphate has sodium. It is always soluble. So remember, if it's soluble, you do not write because that means solid. You write AQ, which means it is aqueous. It is in solution. Ammonium chloride, always soluble. It is going to be aqueous. Cesium hydroxide, zinc nitrate, and sodium chromate. Look at that. All of those I remembered, or I know about the solubility just because of the N rule. So the only two I really need to look at are barium sulfate and calcium sulfide. So let's look at barium sulfate first. When I look at my solubility rules, I need to look for barium and sulfate. So here I see most compounds containing sulfates are soluble. So you might be thinking, okay, it's soluble, but you have to look at the exceptions as well. I have barium bonded with the sulfate. It's an exception, so that means it's insoluble. So if something is insoluble in water, it means that it does not dissolve. And if it doesn't dissolve, it means that it stays as a solid. So the state for an insoluble salt is going to be solid. And an insoluble salt is an ionic compound that is not soluble in water. So it's going to remain a solid. Another way you can think about that is if I have barium sulfate and I put it in water, it's going to remain as barium sulfate, the solid. Notice nothing changes. No solution is made. All right, let's look at calcium sulfide. So the components of calcium sulfide are calcium and sulfide. So I'm going to take that back to my solubility rules and I'm going to look for them. So here I see calcium, but really this is not helpful because I don't have sulfide. So if I come over here, I see I have sulfide, and sulfides are insoluble. So you might be thinking, okay, it's insoluble, it's going to remain a solid. However, look at that. Calcium is one of the exceptions. So calcium sulfide is also soluble and will become aqueous in solution. Go ahead and do the second column. When you get an answer, when you get answers for them, you can email them to me and I will give you extra credit on your Chapter 6 quiz.